Hello everyone, welcome to Hexabot channel. In this video, we'll explore the stepper motor, a special motor that rotates in small, precise steps. This unique property makes it widely used in 3D printers, CNC machines, robotics, and even medical devices. A stepper motor is a synchronous electric motor that converts electrical energy into mechanical motion in discrete angular steps. Unlike regular DC motors, it rotates by fixed angles, typically 1.8 degrees or zero point 0.9 degrees per step. Applications: 3D printers, precise nozzle and bed movement, CNC machines, accurate axis positioning, cameras and gimbals, smooth angle control, electronic valves in HVAC, and refrigeration systems. A stepper motor consists of four main parts: rotor, stator, driver, and controller. The rotor is the rotating core. In simple types, it's a permanent magnet. In hybrid steppers, it has teeth and an axial magnet for high precision. The stator surrounds the rotor with multiple poles wound with copper coils. When energized, they become electromagnets. Bearings hold the shaft steady and reduce friction. The driver switches the current on and off through the coils. The controller, PLC, Arduino CNC, sends pulse and direction signals to the driver. The principle is straightforward. The stator's magnetic field pulls the rotor step by step. When one stator coil is energized, it creates north and south poles. The rotor teeth align with it. The driver then switches to the next coil, pulling the rotor forward again. Repeating this sequence makes the rotor rotate precisely in steps. For example, a motor with 200 steps per revolution moves 1.8 degrees per step. Sending 200 pulses makes one full rotation. Increasing the pulse frequency speeds it up, while reversing the sequence reverses the direction. In modern applications, the driver can shape the current into sine waves, called microstepping. This makes the motion much smoother, with less vibration and higher resolution. The three main types are permanent magnet stepper. Rotor is a permanent magnet, simple design. Variable reluctance stepper. Rotor is toothed soft iron, no magnet. Hybrid stepper combines both, most common for high precision and torque. Pros: precise positioning, holds position without feedback, low cost, easy to use. Cons: torque drops at high speed, can miss steps under heavy load, less efficient than servos. In summary, stepper motors are excellent for systems requiring high precision without complex feedback. Have you used stepper motors in your projects? Share in the comments, and don't forget to like, subscribe, and share to support Hexabot.